Creating a practical administrative tool in Windows PowerShell. This nugget is sort of the final exam. In it, we're going to build a complete administrative tool completely from scratch. We'll start by defining the task that we want to complete and breaking that task down into smaller segments that are a little easier to manage. We'll then write and test individual modules, some of which may be as short as a single line of code. And each module will perform one portion of the task. We'll test those modules individually, and once they're all working, assemble them into a final script. We'll do a little bit of testing and debugging, and we'll wrap up by covering some best practices, just to help keep your larger scripts a little easier to maintain going forward. But of course, before we can do anything, the first thing we need to do is decide exactly what this tool of ours is supposed to accomplish. We're going to create an inventory tool. What we want to do is create a list of servers, go out, connect to each server, and obtain a certain amount of information about each one. The information we're looking for is obviously the computer name. We'll call it the computer system name. We want to get the operating system build number. The build number is the easiest way to determine what version of Windows we're running. We also want to get the service pack major version number, so we can tell if it's on the latest service pack or not. And we want to get a little bit of information about the computer hardware itself. We want to find out how many logical processors it has in it. And we might use that for licensing, for example, to make sure that we have enough licenses for server core licenses for processor cores. And we want to get the system type, because that'll tell us if it's a 32-bit or a 64-bit system. So one of the first things we're going to need to do, of course, is find out exactly where all this information is coming from. But before we do that, let's think a little bit about what we want to do with this information once we've got it. Obviously, one thing we want to do is display it on the screen. We also want the ability to maybe create a CSV file out of it. That's something that's then easy to import into Microsoft Access or SQL Server database, or even into an Excel file, so that we can sort of treat that information as an inventory database of sorts. We may want to look at that in a more report-friendly way, maybe for management purposes, so we also want to be able to write that information out to an HTML file. Maybe put it up on a web server that our help desk has access to, or that other administrators have access to. So we really want to display the information in all those different ways. Now, we also, in addition to being able to display it in those different ways, there's different levels of information that we want to display. For example, we're going to want to do some filtering for service pack updates. In other words, we may want to see all of the Windows Server 2008 machines that are not running the latest service pack. So we're going to want to filter for that type of information. We're also going to want to filter on the system type. We may want to just create some output that includes all of our 64-bit systems or all of our 32-bit systems. And we may also want to sort on logical processors, or even filter on logical processors. That way we can see all of our multi-core machines, maybe our 4-core machines or dual-core machines separately. So we want to gather all this information. We want to be able to display the information in these outputs, and we want to be able to filter and sort by those ways. So now let's spend a little bit of time thinking about what PowerShell can actually do for us. Well, we know that PowerShell can display stuff on the screen and in tables and lists, so we don't need to worry about that, provided, of course, we're giving PowerShell objects to work with. We could take the option also of just formatting the information on the screen ourselves. If we provide PowerShell with objects, we know that it can turn those into a CSV file and take care of displaying them or converting them into an HTML file. So what we're really ideally going to want to do is store all of this information somehow in objects. If we can get all of this information into a set of objects, then PowerShell will take care of the screen, the CSV file, and the HTML file for us. In fact, if we can get all this information into objects, then PowerShell should also be able to do some filtering off all these different properties. So ideally what we're going to want to do is create a script that can go out to multiple different computers, and we'll specify those computers in a text file, just a list of computer names. Connect to each one and retrieve this information, and for each computer that we connect to, create a single object that has these 5 properties. Once we've got these 5 properties built onto the object, we'll output it back to PowerShell, and let PowerShell display it on the screen, convert it to a CSV file, filter it first, or do anything else. So that's sort of the broad stroke of what we need to get PowerShell to do for us. So now let's take all of this and kind of break it down. Let's figure out exactly what tools and what technologies and what capabilities we're going to need. So let's call up a fresh whiteboard here so we have a new place to write. We know that in order to retrieve all of this information, we're going to be connecting to remote computers. Now in PowerShell version 1, really the only way we've got to connect to remote computers is WMI, which means we're going to be using the getWMIObject commandlet to actually retrieve the information from the remote computers. Now one thing we need to figure out is what WMI classes we're actually going to query in order to get the information that we're after. And what else do we need to do over here? Well, we need to get information out to the screen, possibly in a table, possibly in a list, but either way it's going to be one of the format commandlets. So format list or format table. CSV file and HTML files. Well, to get it into a CSV file, we'll use export CSV. And to convert things to HTML, we'll use the convert to HTML. But that just creates the HTML. We're actually going to have to pipe that output to outFile to get it into a text file that we can then save on an intranet web server maybe. Now, as far as filtering all these things and sorting them, we've got a couple of commandlets. We've got where_object, which is going to allow us to sort or filter those things, and then we've got sort_object, which is going to allow us to sort them and change the order that they're in. So really, Windows PowerShell is going to make it easy to do all of these things, and the only thing we really have to spend some time working on is this WMI business. So that's going to simplify our lives a little bit. And we also said that we want to output the information as objects. So there's a couple of other commands that we're going to need to look at. We're going to need new object to create the new object for the first time, and then we're going to need add member, and that's what we're going to use to add the properties to the object. And then the last thing we're going to need is write output, and that's what's going to allow us to take that object we've created and give it off to PowerShell so that it can do all these other things, formatting it, filtering it, sorting it, converting it to HTML, and exporting it to CSV. So this is a pretty good list of all the commandlets we're going to need. Almost. I guess the one thing we still have to figure out is how we're going to get that list of computer names in from the text file. That would be get content. So now that we know all this information, we might sit back and take a few minutes to read the help files on those, maybe look at some of the examples that are in the help files and really get comfortable playing with those. In fact, we're going to really try and break these down so that we're only working with one at a time and really kind of testing and doing some proof of concept before we pull everything together into one great big script. So the first thing I really want to focus on, though, is the big question mark here, which is which WMI classes are we actually going to be querying? Now, unfortunately, there's no great super easy way to do that. You just kind of have to use a little bit of know-how and a little bit of, well, honestly, guesswork. I like to start my guesswork on Google. And one little tip with WMI that'll really get you far is knowing that most of the core operating system and computer hardware classes all start with the prefix win32_. So I'm going to include that as my first search term, and I'm putting it in quotation marks so that Google treats that underscore as part of the literal search term. Otherwise, Google tends to strip off punctuation and things. Next, we're going to put WMI, because that's the technology we're working with. And, well, I think the next thing we want probably is the build number. That's one of the things we said we want. Let's see what comes up here. See, there's a WMI tutorial, scripting I, bunch of websites in here, and okay, so there's information about all different WMI classes and some blogs and stuff like that. So we browse through these. Another way you've got to do it, if you don't want to go through the Google way, which we could, I just want to kind of show you both ways, is the WMI Explorer tool. And again, that was a free tool. You can get it from scriptinganswers.com. Just go to the Tools zone, and I'll pull that up right now. One of the reasons I like this rather than going on the web is because this lets me actually work with the WMI information that's on my computer. There's no theory here. This is actual practical stuff. root CIMv2 is the place to start, although you'll see some other interesting things in here. This is where, again, all the core operating system and computer hardware classes are located. And all the good stuff starts with Win32, so I'm just going to fast forward right to that. And I'm honestly just going to browse. Eventually, if you read through some of these things, you'll come across something that looks good. For example, here we go, Win32 computer system. That might tell me something about processors and so forth. And the thing to remember is to look on the Instances tab. So I've got one instance of Win32_computer system, and we'll scroll through the properties to see what this offers. And it actually does have some good information. We've got number of logical processors, so that's one of the things we wanted. And let's see if it'll tell us what kind of processors those are, 32-bit or maybe 64-bit. And I'm really looking at the values over here. I want to see 32-bit or x86 or x86-based PC. Right? So the property name is system type. Now this isn't having anything about the operating system. Right, so let's see if we have a class up here named operating system. That would be under the O's. Oh, Win32 operating system. All right, let's see if that's got what we want. We'll click on the one instance of that we have. Build number. That's definitely one of the properties we're going to look at. And we also wanted to look for service pack version. So here we go, service pack major version. So that's pretty much everything we need. And yeah, that's going to do it. Oh, and look, it's even got the computer name. So we'll know the computer name already, since we're going to need to know the computer name to connect to the computer. But it's nice that it's on this object if we wanted to, pull it off there for some reason. Right, so great, that's pretty much all the information that we need. We've broken things down and figured out exactly which commandlets we're going to need. So we're ready to start writing some individual modules and really doing some proof of concept work. And I'm really not even going to open my script editor yet. We're just going to kind of play around in the shell, do some kind of ad hoc work. Not really going to worry about connecting to a remote computer even right now. We're just going to worry about the local computer and kind of get things working, make sure we can get what we want. So let's start by doing get wmyObject Win32 computer system. Okay, well that's some information. It's not really all we wanted, so let's pipe that to format list star so we can get all the properties out of it. Yeah, here's some good stuff. System type and number of logical processors. Perfect. So let's do that again. And this time, instead of formatting it as a list, let's actually save that in a variable called WMI. And now let's create an object, new object, PS object. And we're going to pipe that to, well, before we do anything else, let's just double check and make sure WMI.number of logical processors. Okay, 1, that's the information we want. So now all we have to do is pipe obj to add member, tell it we're adding a new note property named processors, and we're going to set that equal to whatever's in number of logical processors. We'll do the same thing again, only this time we're going to add a note property named, I want to call it architecture, and we are going to add that system type. So now let's look at that obj object. Great. We'll add another one called computer name, and we're just going to set this to localhost because that's the one we're working with. Take a look at our object now. Wonderful. And so now we need to go after that Win32 operating system class. So let's set WMI equal to get WMI object Win32 operating system. And take a look at that. We'll pipe it to all there. So service pack major version and build number. All right, so we'll take obj, pipe it to add member again, add another note property. This time we'll call it build, and this will be WMI.buildNumber. One more time, and we're just going to call this SP version, and I'm going to grab the service pack major version property. Let's take a look at our object. Now we've gotten more than 4 properties on here now. So PowerShell has stopped formatting it as a table, started formatting it as a list, but let's make sure we can still format it as a table if we want to. Yep, that still works. Format table. So what are some of the other things we needed to be able to do with this object? Well, we wanted to export it to a CSV file. Oops. Need to give it a directory that works. Here's a good time to check that get content commandlet that we mentioned, and let's just take a look at that CSV file to make sure that it picked up all the information we're after. Fantastic. We said we wanted to convert it to HTML and then out that to a file. So we'll actually take a look at that in Windows Explorer. Okay, that's got all the information we want. So we've pretty much conquered all of the different tasks that we need. In fact, if we had started a transcript before we started doing all this experimentation, we'd actually have a transcript file that has, well, pretty much all the commands that we need, and we've tested them and we've seen how to use them, and we've gotten them working just right here in the shell. If we got an error for something, then we were able to just sort of deal with it ad hoc. We're not really writing a script. However, now that we've gotten all these commands, really writing the script is almost a matter of copying and pasting them just in the right order. So that's what we're going to do next. We're going to actually open up our script editor, start pulling some of those same commands in, and building it together and assembling that final script. Now I'm actually going to forego the laziness and not copy and paste it. I'm just going to open up my script editor and we'll start from scratch. But you're going to see a lot of the same commands. So we know that we need to go out and get that information. So I'm going to write a function that goes out and gets information. Now, one of the things we know is that we want to get a list of computer names from a text file. So I'm going to start with that. Get content, C demo computers.txt. So let's just take a little second to make sure we actually have that file, computers.txt. And yeah, that's got a few names in there, including one called not available. Just to kind of keep our initial test simple, I'm just going to limit this to 2 computers that I know are available. And we'll do some other testing later. And that's kind of a key thing when you start writing this. Don't start with the final product. Start simple. Just test with a couple things that you know are going to work okay, so that your script itself is the only real moving part that you have to deal with. There's no sense in adding 15 computer names in here if one of them is going to cause a problem, because then you're not only going to be writing and debugging a script, you're going to be dealing with connectivity issues or permissions issues. So just try to limit it to the ones that you know for a fact are going to work. So I'm going to close this. So we have our computer name file, and what I want to be able to do is get all those computer names and pipe them to a commandlet, get inventory info. Well, there's no such commandlet, so I'm going to write a filtering function. Function get inventory info. And now remember, the function has to appear before it's actually used. So that's why I'm writing the function above the command that uses the function. Inside this, because I want it to be a filtering function, I'm going to start with my begin, process, and end script blocks. I don't really need to put anything in begin or end, and I don't need to include them here, but I just like to do it for completeness. The first thing I want to do is create a new object of a PS object. And I'm going to go ahead and attach a note property called computer name. You know what, let's be nice and really capitalize this and make it nice and pretty. And this is going to contain the current pipeline object. So that's how we're going to get whatever the current pipeline object is into that note property. Next, we're going to get the computer system. Get WMI object, Win32 computer system from the computer in the current pipeline object. A little bit later, we're going to get the OS info as well, and that's going to be get WMI object, Win32 operating system from whatever computer name is in the current pipeline object. Once we've gotten the computer system back, we're really ready to add properties again. So object, pipe to add member, note property, and one of the ones we're going to add is processors, and that's going to be whatever's in comp system dot number of logical processors. And the other piece of information we're going to pull from here is the system type. We're going to call that architecture. And that comes from the compsystem.systemType property. Now a little bit lower, where we've retrieved the operating system information, we can pretty much just do the same thing. Could be copying and pasting here, but hey, typing is fun. So let's add the SP version, and that's going to be whatever's in os.servicepack.major version. And then we're going to add one last note property called build, and that will be whatever's in os.buildNumber. Now I could test this right now. In fact, I'm going to save it. We'll call this inventory.ps1. I could test this right now with a couple of computer names, but you know what? Let's simplify things. Let's test it with a computer that we know for a fact is working. So I'm going to keep this line here, but I'm going to comment it out so that it doesn't actually run. And we're just going to take localhost and pipe it to get inventory info. That way we've got a nice simple thing to try to begin with. So let's save it, run it in the shell, and we got nothing. And this is why there's no point in going on and testing this with 50 computers, because we can't even get it working with one computer. Now, however, we know that it's not a problem connecting to the 50 other computers. The problem's got to be with our script. We know localhost works, so that really helps kind of narrow down the number of moving parts there could be. So let's kind of walk through the process here. We've created our object. We've added our computer name. Got this from WMI. That might not be working, but you know we know this is working. We're just adding a static value to it. Okay, you know what? Let's do a little debugging. Let's set our debug preference to continue. And just at the top of this block, let's find out what's in $_, right? Debug. Escape $_ contains $_. Let's run it again. Okay, $_ contains localhost. That's great. Well, then this command right here really ought to work just fine. Tell you what though, let's copy it to the clipboard, go into the shell, paste that, and replace $_ with localhost, since we know that's what it contains. Yeah, that command works. Okay, well, I'm going to turn debugging off by changing this to silently continue. We know that line 9 works fine. I'm going to assume that line 13 works fine. So, oh, you know what? We never actually wrote this object out to the pipeline. Write output obj. Okay, we've turned debugging off. Let's run this again. Hey, there's our object. Got the right computer name, logical processors, architecture, service pack version, and build. Fantastic. Now that we've gotten that working with one object, it really should just work with many objects. So let's give it those two computer names from computers.txt. Fantastic. All right, let's go make one more change and force that to format as a table with auto sizing. Great, we're getting exactly the information we need. And notice that because we took the time to sort of make the property names nice and pretty capitalized in our script, they show up that way in the shell too. So we've really done a little bit of testing and a little bit of debugging, and we've gotten this script really to where it needs to be. All we need to do to inventory more computers is just add those computers to our computers.txt file. Pipe them to get inventory info, and we can do whatever we want. All right, so let's hang on to that command as a sort of reference and do get content, and we're going to get demo computers.txt, pipe them to get inventory info, and this time I just want to keep the ones where the build property of whatever comes out of get inventory info is equal to 6001. Let's run this. Okay, everybody equals 6001. And then I want to export that to a CSV file named win2008.csv. Run it again. Okay, well, it didn't blow up on us. Let's check out that File. Great, so we're getting our output to CSV as well. Let's see if instead of exporting it to CSV, we can convert to HTML, and then out that to a file, win2008.htm. Run it again. Great, and now let's see if we can open that file. Fantastic. So we're really getting all of the filtering capabilities we need, and all that's coming from PowerShell, from these common core commandlets like where object, convert to HTML, everything else. So really, let's leave this as a reference in there too, save it. Really, we're kind of done. We found a bug, we were able to debug that, we got the final script assembled, and we've created a very useful inventory tool that has a lot of different purposes. This isn't just good for finding out who's on the latest service pack, it's good for finding out, well, how many computers we have that are running 32-bit processors or 64-bit processors. Filtering it so that we're only looking at 64-bit processors that have more than one logical processor and are running Windows Server 2008. Without making any changes to our function here, we've got a lot of capability to use this in a lot of different ways. So now let's talk about adding some best practices to this. One best practice I like to do is to always add these write debug calls, and we could probably add a few more of those in here just in case we ever need to debug this in the future. I don't mind leaving those in there because I can turn the actual debugging output off, and it's not slowing PowerShell down or anything to have that in there. Another best practice might be to trap for errors. We know that it's possible for getWMyObject to run into an error. Maybe it can't connect to a computer, or maybe there's one in here we don't have permission to, or maybe we just typoed a computer name and it doesn't exist on our network. So we could trap that error and deal with it. Another thing that we really should do is add some comments. So let's start with create new object and attach computer name as a property. And we'll go down and just every few lines explain what it is you're doing. Get the computer system info. Attach two properties to our object. Next we're going to get the OS info and attach two properties. And finally, output our object to the pipeline. Another best practice might be to check this into a source control solution in our organization, so that if I need to make a change to this in the future and I accidentally mess something up, I can always go back and get this working version. Also so that other administrators have access to it, keeping it in a central repository so that other administrators can pull this down and possibly use it or expand it. Right? Because if there's some other information that someone else needs to get that we're not getting here, well, it's pretty easy to take this, expand it, and add that additional information to our custom object. So just a few very simple best practices in there to kind of make things a little bit easier going forward. Keep in mind that 6 months from now, you might not remember why you stuck this particular line of code in there, or you might not remember why you put this there. So these comments just kind of help you remember those things. Keeping it in source control helps make sure that it's going to be around. So those are kind of just a few simple best practices, not really any much of a burden, and you can kind of get yourself in the habit of doing them as you go along. But the real trick is to remember that we didn't need to start out sitting down at this computer and writing that whole script from scratch. We kind of thought about what we needed, broke it down into little tasks, went into PowerShell and played with a few of those things to make sure we understood how they worked and got them working, kind of, figured out all the tricky bits, just one line at a time. Once we had pretty much everything figured out, it wasn't a big deal to either retype it or even copy and paste it out of a transcript into a script. Create that filtering function, and because everything was being output as objects, PowerShell really took over from there and did the rest of the work for us. So in this nugget, we assembled a complete practical administrative tool right in Windows PowerShell entirely from scratch. Part of what I want you to take away from this was the process that we used to actually create that tool. We started by defining the task that we wanted to complete, and we did that in some detail. We were also very specific about the end results that we needed to see. We broke that down into subtasks and identified the individual bits that PowerShell was already capable of handling so that we weren't reinventing the wheel. Once we'd identified the bits that we needed to write, we wrote and test individual modules. That way we were only working with a smaller number of moving parts at once, and it was a little bit easier to test those and get them working. We assembled the final script, got it working by testing and debugging it, and then we went back and made sure that we were following some best practices to keep the script easy to read, easy to maintain going forward. I hope this has been informative for you, and I'd like to thank you for viewing.